So here we are on the lesson 5 notes. So module, so these again are notes. And that's really too thick. So notes for module 1, topic 1, lesson 5. All right, so you kind of dealt with in lesson 4, distance formula, a little bit of classifying. So now we're going to deal with perimeter and area. So doing distance formula there and that sort of thing. All right, now this one's pretty straightforward. We got to consider rectangle ABCD, and we got to determine the perimeter of ABCD. So remember, the perimeter is calculated by adding all the side lengths. So all we got to do is just kind of count up the lengths and add them up. So we're starting here, so 1, 2, and then 1, 2, 3, 4, 5, 6. 1, 2, and 1, 2, 3, 4, 5, 6. So adding them all up, we get 6 plus 6 is 12, plus 4, or 2 plus 2. So we get that we have a total of 16 units for the perimeter. Okay, and remember, anytime you're doing area and perimeter, you got to always have some sort of units. All right, so then they ask us to determine the area of a rectangle. So remember, for area of a rectangle, it's base times height, where A represents the area, B represents the base, and H represents the height. I want to make sure that you understand height in this case is always the perpendicular segment to the base. Because you start dealing with parallelograms, trapezoids, all sorts of stuff that have slanted sides, and those slants are not the height. They're the slant height, but they're not the actual height. So it has to be a perpendicular segment to the base. Luckily here, this segment is perpendicular to that segment, so you can call 6 the base, 2 the height, or you can call 2 the base and 6 the height. Either way, the area of the rectangle, so if you use the formula base times height, 6 times 2 is going to be 12 units squared. And remember, area always is squared. And you could also write or see it written square units. Both are acceptable. And that. Just keep in mind the square goes on the units, not on the 12. Okay? All right, so that's all we're going to do really on 71. We're going to skip ahead to page 72 right now. These notes will go pretty quick today. All right, so then when a rectangle is graphed along grid lines, you can determine the perimeter and area by simply counting units or square units on the coordinate plane. Okay, so it's true for if the coordinates are integers. If they're fractions or decimals, then it turns into something else. So notice here that we have a little bit of a situation where they've changed the intervals along the axis. It's no longer where 1 square is 1 unit. Now we have 4 squares is 300 units. So we need to think through, how am I going to figure out what 1 square if 4 squares is 300? So I need to know what 1 square equals, but I know that 4 squares equals 300. So the easiest way to do it is just take 300 and divide it by 4. Okay, and you get that 1 square is equal to 75. Okay. All right, so you just kind of need to think through here. We actually now have 1, 2, 3, 4, 5, 6 units, but it's a length of 1 unit, or 1 square is 75, so we got to take 6 and multiply it by 75, and we get 450 units for this length here. And then same thing, we're going up here, so we have 1, 2, 3, so we actually have 3 squares, but each square is 75 units, so you need to take 3, multiply it by 75, Okay, and you get 225 units. So then you sit there and calculate the area and the perimeter the same way. Now, you could do the times 75 at the very end instead of doing it as you're in there. But that gets into a little bit of difficulty when you're doing area because you're not just multiplying it by 75. So you have to kind of keep that in your brain in that sense. So here we have 450 for perimeter plus 225 plus 450 plus 225. Or if you want to do it 900 plus 450 gets me 1350 units for the perimeter. Okay. And then for the area, so that's perimeter. So area then is going to be 450 times 225, which I won't make you get your calculator out for, but 101, 250. So 101,250 units squared. Okay. All right. So the question then is, what would happen if you double the height of the rectangle? How would that affect its area? So if I double the height, I'm going to take 225 as being the height. So I'm going to double the height. And I now have a rectangle that kind of looks like that. Now, instead of 250 for my height, I have a height of, or 225 for my height, I have a height of 450. So my new height, I'm going to kind of bring this down here. So my new height is 450. And if I take my previous length, or my base, times my height, 450 times 450, I get my new area to be 202,500 units squared. So basically, doubling the height, I have now doubled the area. Okay. All right, and so let's say I would have, if I didn't double the height, but I doubled the base. So say I went out here, 1, 2, 3, 4, 5, 6, and I doubled the base. So now I still have a height of 225, but I have a base of 900. So what's going to happen there? So my new base now is 900. My height is still 225, so I take 900 times 225, and my new area is going to be 202,500 units squared. So again, it doubled the area. So if all you do is double one of the units, then it doubles the area. What do you think would happen if we ended up doubling both the base and the height? Well, you can kind of visualize it. It's going to be 1, 2, 3, 4 times as big. So just keep that in mind. If you only double one of the dimensions, then the area doubles. If you double both of the dimensions, then the area is 4 times as big. So if you double both dimensions, the area is 4 times as big. As the original. Okay. All right, so we're going to skip ahead to 75 because today on your assignment, you're going to be finding perimeter and area of rectangles and triangles. So I want to do page 75. Which gets us this figure here. We're going to determine the perimeter and area of triangle DEF. They give us the coordinates there, and we'll come back to those in just a minute. All right, but we need to remember, actually I'll just leave it up there like that. We need to remember that area of a triangle is found by base times height divided by 2, or another way of writing it is 1/2 base times height. Remember, base times height is how you find the area of a quadrilateral, and so a triangle is just looked at as half of a quadrilateral, so we're dealing with it in that sense. Okay? All right, so let's label our points here. So we have E, which is 3. Notice again that we have squares along the x-axis go by 1s, but squares along the y-axis go by 2s. So you have to always make sure that you're clear on what your units and what your intervals are. So this is 3, -1. F is 3, -9. And D is -5, -9. All right, so now I can kind of pull this up just a little bit. All right, so now we need to find the area and the perimeter. Well, first off, let's do, we got to just find the lengths. So I can sit here and count. I'm going by 1s. So finding the length of DF here. So I'm going 1, 2, 3, 4, 5, 6, 7, 8. So that has a length of 8. Or I could have sat there and said, okay, I started at +3, ended at -5. That's 8 units. Either way. All right. So now let's find EF. Okay. So again, I have to remember that each half square is 1, or each full square is 2. So however you want to do it. So if you want to go 1, 2, 3, 4, 5, 6, 7, 8 as well on that. Or looking at the y coordinates, I start at -1, I'm going down to -9, and that also is 8. All right, so now I got to find the length of DE here. Well, luckily, it's a nice little right triangle because we have a horizontal and vertical, which makes a right angle. So we can use a Pythagorean theorem. So again, a squared plus b squared equals c squared. So 8 and 8 in this case are both our legs. So we have 8 squared plus 8 squared equals c squared. So 64 plus 64 is equal to c squared. So that's 128. And again, I don't want to find out what c squared is. I want to know what c, so I'm going to take the square root of both sides. I get c is equal to the square root of 128, which is great. But I actually want to find the length of the hypotenuse in this case. And I want to be able to use it with perimeter and area. So I need to find the decimal approximation. So this is approximately 11.31. Okay. All right. So now I have everything that I need. So for perimeter, it's going to be 8 plus 8 plus 11.31. Which 8 plus 8 is 16, 16 plus 11 is 27, so this is 27.31 units. Okay. All right, the area, didn't need the hypotenuse for the area, but base times height, in this case, the base and the height of a triangle are always, my pen is goofing up, always meet at a 90 degree. So base and height of a triangle always meet at a 90 degrees. So in this case, my 90 degrees is right there, so my base is 8 and my height is 8. So I have 8 times 8 divided by 2. 8 times 8 is 64. So I have 32 units squared. Okay. All right, and we can go through and see real quick, what if you doubled the height? Okay. I'm not going to worry about what the coordinates are. I mean, if I double the height, I can figure that out. But how does it affect the area? So my height, let's just say, is 8, because it's either going to be 8 or 8. They're the same number. So now I have 8, or area is equal to 16 times 8 divided by 2. Okay. 16 times 8 gives me, oh, what is that? 1651. 28 divided by 2, which is 64 units squared. So it doubled based on the original again. So it doesn't matter if it's a triangle or a rectangle, quadrilateral, it's still going to double if you double the area when double one dimension. So when you double either the base or the height, whoops, dimension, not dimensions, it doubles the area as well. And the same thing would be if I doubled the area and doubled the base, or doubled the height and doubled the base, then it would be 4 times as big. Okay? All right. So that's it. Your homework tonight, you're going to be doing perimeter and area of shapes on a coordinate plane. You're going to have to do a little bit of Pythagorean theorem or distance formula to be able to figure out the distance between two points. But again, most of the time you can always make it into a right triangle. All right.